Contrary to previous videos stating that they were the last video in this section, this video is really the last video in the section on scientific measurement. We're going to be talking about precision and accuracy. Actually, we're going to talk about accuracy, then precision. So we'll start with accuracy. The definition of accuracy is how close your data is to the correct answer. You can think of it as dots on a dartboard. Here you've got a very accurate dot thrower. The dots are all in the bullseye. You are close to the correct value. Here you have dots which are close together but are not near the bullseye. These throws were inaccurate. Precision is how close each piece of data is to each other. So for this dartboard, these dots are inaccurate, but they are precise. They are closely clumped together. Here, the dots are not clumped close together. We would say this is imprecise. So it turns out you can have several combinations. You can be accurate and precise, as evidenced by 3 dots in the bullseye. You can be inaccurate but precise. You can have the 3 dots being close together but away from the bullseye. And then the ever popular inaccurate and imprecise, where things are just scattered all over the place. It's also possible, if you have some luck, to be accurate but imprecise, but we're not going to get into that. So we're going to try and judge the accuracy of something. There are 2 methodology. The first one is good, where you calculate something called the error. The error is the value that you got minus the value you should have gotten, technically known as experimental value minus expected value. That's good, but there is a better method, and this is the one we'll use in class. It's called the percent error, which is the experimental value minus the expected value divided by the expected value times 100. The smaller that number is, the more accurate your data is. So here's one example. I let a student weigh a piece of metal. I've already determined that the piece of metal weighs 22.3 grams. Therefore, the 22.3 grams is the expected value. The student runs 5 trials. Here's the data that was obtained. We see that the mean is 22.0 grams. Okay, how accurate are we? Well, the mean value, 22.0 grams, is the experimental value. So, how accurate? We'll use percent error, which is experimental value minus expected value divided by expected value times 100. So using that equation, we know that the experimental value is 22.0 grams. The expected value is 22.3 grams. Now you just have to plug and chug. 22.0 grams minus 22.3 grams divided by 22.3 grams times 100 is the percent error. You get negative 1.34% error. The negative sign just means that the experimental value is less than the expected value. Okay, in another experiment, the students are going to determine the density of a metal block, and this is the data that they obtain. Well, how accurate is this data? In order to do this, you need to know that the actual density is 19.25 grams per milliliter. Once you know this, calculations, so stop the video, do the calculations, return, and we'll run through the answer. Go. Okay, the mean value is 19.75 grams per milliliter. So to determine how accurate this data is, we're going to use the percent error. We pull up the equation, the experimental minus the expected divided by the expected times 100. The experimental value is 19.75 grams per milliliter. The expected value is 19.25 grams per milliliter. Once again, just plug and chug. There are the values plugged in. You do the calculations and you get a percent error of 2.60. 2.60 is positive, which means your experimental value was just higher than your expected value. So to review all of this, accuracy is how close to the right answer you got. How close to the bullseye. Close or not so close. Percent error, which is the experimental value minus the expected value divided by the expected value times 100, is how we determine accuracy. If the value you get is positive, the experimental value is too large. If the value you get, the percentage you get, is negative, The experimental value is too small. Precision is how close each data point is to the other data points. There are fancy ways of figuring that out, but right now we're just going to do it by data. How close do you think the dots are? So that finishes section 2. After you guys have taken the test and done all the labs, we'll move on to section 3, which is where we'll really start to talk about chemistry.